Hello everyone, in our class today we'll be working on sizes and sum of interior angles, okay, interior angles of a polygon, okay. So when we look at a polygon is a shape with number of sizes, either regular or irregular. So let us tabulate a 3-column table, okay. So we have this to be the polygon, okay, the number of sizes, okay, and here we have sum of interior angles, okay, interior angles. So we have this as this. So let's consider triangle, okay. We look at quadrilateral, we look at pentagon, we have hexagon, okay. So let's look at septagon. Okay, so for a triangle is a 3-sided shape, okay. We all know a triangle, okay. For equal sizes is equilateral triangle, okay. So for example, how do we determine the sum of interior angles of a triangle? We can do that using this formula, which is n minus 2 times 180 degree, okay. So we use this formula to determine sum of interior angles of any polygon. So for a triangle, to determine that, we say a triangle, okay, so that would be n minus 2 times 180 degree. Why are we using this formula? Because we want to determine the sum of interior angles of this triangle. So for n stand for the number of sizes. So a triangle has 3 sizes. So we say 3 minus 2 times 180 degree. So we have this to be 1 times 180 degree. We have this to be 180 degrees. So that means the sum of interior angles of this triangle is 180 degree. Okay, for a quadrilateral are four-sided shape, okay. So it's a quadrilateral. So how do I determine the sum of interior angles of its quadrilateral? So for this quadrilateral, I'll say n minus 2 times 180 degree. So I'm still applying the same formula. So for 4, which is the number of sizes, so for 4 minus 2 times 180 degree, so I have this to be 2 times 180 degree. So this gives me 360 degrees. So that means the total interior angles of a quadrilateral is 360 degree, okay. So let's move to pentagon. Okay, a pentagon is a 5-sided shape, okay. So it's a 5-sided shape. So when n is 5 in this case, okay, so by the time you apply this to determine the total sum of interior angles of this pentagon, which is a 5-sided shape, so in this case we have n to be 5 times 180 degrees. So here we have this to be 3 times 180 degrees. So by the time we multiply this, we should have 540 degree, okay. So 3 times 6 is 24, so this is 540 degrees. So sum of interior angles, which is a 5-sided shape, is 540 degree, okay. So for hexagon in this case, this is a 6-sided shape. So when n is 6 in this case, so we can determine the sum of interior angles. So that is 6 minus 2, okay, times 180. So degree, angles are measured in degrees. So we have 4 times 180 degrees. So by the time we calculate this, we have 180 times 4. This one is 32. So we have this to be 720 degree, okay. So that means for hexagon to be a 6-sided shape, okay, so we can say the sum of interior angles of an hexagon is 720 degree. And for septagon is a 7-sided shape, okay. So to determine that, we say for septagon, okay, so we say n minus 2 times 180 degree, okay. So for n to be 7, so we have 7 minus 2 times 180 degree. So here we have 5 to be this times 180. So by the time we calculate this, we have 180 times 5. So this is 0, this is 40. So we have this to be 900 degree, which stands for the sum of the total sum of the interior angles of a septangle. So the same thing applies when we have other polygons, and we can easily determine the sizes and the sum of their interior angles. Okay, other polygons such as we have octagon, which is an 8-sided shape. Okay, we have nonagon, okay, which is 9-sided shape. We have decagon, okay, which is a 10-sided shape, etc. So let's also look at this example. We have a question that says, what is the size of each interior angle of a regular pentagon? Okay, solution. So for the first question, we have to determine the size of each interior angle of a regular pentagon. Okay, so we know that a pentagon is a 5-sided shape. Okay, so how do we go about this? So for a pentagon, okay, so the first thing we do, let us determine, okay, let's determine the total sum of angles of a pentagon. So how do we do that? We use this formula, which is sum of angles in the pentagon. Okay, so that is 180 degree, the total sum. So for pentagon, which is a 5-sided shape, so in this case, our n is 5. Okay, so we go with this. So here we say 5 minus 2 times 180 degree. So for 5 minus 2, we have to be 3 times 180 degree. Okay, so by the time we multiply this, we have this to be, okay, this is 24. So this is 540 degree. But the question says we should find the size of each interior angle, not the sum. Okay, so this one is the total, which is the sum of all angles. Okay, sum of all angles in the polygon, which is the pentagon, but we have to determine the size of each interior angle. So what do we do? So to determine the size of each interior angle, okay, so the size of each interior angle will be determined as, so since we have the total sum to be 540 degree, so we divide by 5 in this case because we are working with 5 sizes. So when we look at this, we divide this, we have this to be 108 degrees. So that means the size of each angle of the pentagon is 108 degrees. So let's look at the second question. 3 angles of a quadrilateral are 85 degrees, 95 degrees, 72 degrees. So we know a quadrilateral is a 4-sided shape with 4 angles. Okay, so we have to find the 4th angle. So for this quadrilateral, okay, which is a 4-sided shape, so in this case n equals 4. So let's determine the sum of angles, total sum of angles in this quadrilateral using this formula, n minus 2 times 180 degree. Okay, so when we do that, we have something like this. For n to be 4, 4 minus 2 times 180 degree. So we have here 2 times 180 degree. So this one's to be 360 degree, which stands for the total angles in the quadrilateral. But we are giving 3 angles out of the 4, and we have to determine the 4th angle. Since we have figured out the total, so we can easily add up all these 3 angles given to us, okay, by saying 85 degree, 95 degree, okay, plus 70 degree. So when we sum this up, we have this as 10, okay, this should be 18, okay, and this to be 18 plus 7 should be 25. That's 250 degree. So if this stands for the sum of the 3 angles, okay, so that means to determine the 4th angle, we easily subtract this from this. So we have taken this from 360, so we have this to be 0, 1, 1. So that means the size of the 4th angle is 110 degree. Thank you very much.